Hi, this is Shakil Ahmed. In this video, we will discuss about merging the different data frames according to different type of situations. Uh, as we have two different data sets, we can merge data according to a different identifier that is called identity variable that should be in both data sets, and that may be we may have more than two variables, the id variables. Then still we can merge the two data frame, but we have different options whether we should keep all the values in both data sets. As when we are merging, we have different unmatched data set. For example, some values, some observations on some variables may have for only data 2, and for some variables we have observations for only data 1. Then what should we do? Basically, we just got confused. So we have four different options, and we will discuss this thing in detail in this lecture. Uh, I can just show you an example. If you can see, we have two data sets. For example, this is data 1, this is data 2. Then we can join, we can merge the data in these four scenarios. Inner join means we are just keeping the cases that are both in data 1 and data 2. Means those variable uh, uh, will be just basically we include the cases that are matched in data 1 and data 2, that is the intersection of the two data sets. And the left join means we will keep all the observations in data 1, and we will get the data only the matched observations from data 2, and other variables will be just other values will be just as a and a. So the length of this data set will be equal to the length of our first data set, that is called left join. And right join, right outer, that is called, these three are outer commands basically. This is the inner one. So the right outer means we are keeping all the variable all the values of second data set, and we will get only the matched values that are also be a part of the second data set and first data set. So we are keeping the cases that are available in uh, this will include all the values, all the observations are cases that are available in data 2, not in data 1. But it will only include the cases that are also available in data 2. But if the cases are only available in data 1, then those will be excluded in the merged data. And the outer join includes, that is the union of the two data set, that includes all observations. This is just like an append command. When we have no match data set, it includes all the values, all the cases in data 1, and include all the cases in data 2. But if there are match values, for example, some cases are both in data 1 and data 2, then it will just write those cases only once. So it is the concept of union. So let's do these in R. Hope you have understand. We have a data set consists of an ID variable and X, Y, and Z, four variables. And we can write the data frame. This is data frame. We can call it data frame 1. Uh, just I have named here. And the data 2, you can just write it is data 1. and the data 2 consists of again ID2. This ID is starting from 6 to 15. This ID is starting from 1 to 10. For example, we have 10 people, first 10 people in data set 1, and from 6 to 15 individuals are both in both data sets. So these people from 6 to 10 are available in both data sets. And we can run the ID2 and X2, Y2, Z2. We have almost same variables, just with different names, and we get the data frame 2. So we have two data sets with almost same variables. If there are different variables, then those data will be not included for accordingly. If, for example, for one variable we have only data set for only one in one data set, then that will be included in the outer join, but not in inner join. That in inner join, that variable will be just excluded from the data. For inner join, we should have the variables in both data sets. Then we can match them. So now we can use the join commands. We have first inner join that merges two data sets and keep only the cases which are included in both data sets. That is the intersection of the two data sets. So let's see what we will get. We have data frame 1, and merge command consists of data frame 1, data frame 2, and this is the ID in data 1, this is the ID in data 2. Mostly we have same name, then you can just write by and ID. You don't need to write by dot x and by dot y. You can just write by is equal to ID. When the variable merging variable uh, has same name in both data sets, and all is equal to false, it means we are doing inner join. And if we write all is equal to true, it means we are keeping all the values that are available in both data sets, that are present in both data sets. So let's run. So just we can see starting from ID 6 to 10, those cases are present in both uh, data sets 6, 7, 8, 9, and 10. So we are just we get just only those cases that are available in both data sets. This is called inner join. That is just intersection of the two data sets. And the outer join consists of the union of the two data set, that they would include all the data set, but it will just give the NA for the observations for the cases where data 1 is available. The variables, the value of the observations corresponding to the variables in data set 1 will be just present in data 1, and it will be empty for data 2 if they they are not exist in data 2. So let's see. And the outer join command, we are just keeping all is equal to true, and you can see now you can see that we have all values. We have now 15 values, 10 for data 1 and 10 for data 2. But these, for example, 6 to 10 values are available in both data sets. So these values are just coming only one. So this is the just concept of union. So these variables are available for data 1, not in data 2, and these values, these cases are available in data 2, but not in data 1. But it is including all the cases and data are available in data 1 and data 2. The next one is the left join or left outer command. Left outer means we are just including all the cases in available in X. So it will include only 10 observations. Just it will exclude these values. Basically, these cases are available in data 2 but not in data 1. But we are concerned with data 1. We are keeping the all observations in data 1 and including only match variables, only match cases from data 2. We are not interested in match unmatched cases that are available in data 2. So this is used for uh, such type of scenarios. So we can just write here all dot x is equal to 2. It means x means the first data set. You can we are naming x is equal to df1, y is equal to df2, and then by x this is the id for the x variant first data set. This is the id for second data set, and all dot x is equal to 2. So you can see we have only you can see only 10 values. These are of from data 1, and we are including only those cases that are matched from the data set in the values in data set 1. So we are including only matched values from data set. We just skip other values. These values are excluded from the data 2. So we are not interested in the values of in dataset 2 that are not not matching with the persons or identities in dataset 1. And the last one is the right outer that include the cases, all cases in dataset 2, but only matched cases from dataset 1. So you can see these are given from ID 6 to ID 15. These are the IDs from dataset for. We are including all dataset from data 2, but only the matched values from data 1. So this is the uh, a right outer uh, join function. We can in most of the cases we may have more than two identities to merge. For example, in uh, health related surveys, we the survey is conducted in merging order. For example, we first have cluster ID, and then we may have the household ID, and then uh, individual's ID within household. So we may have more than three identities or four identities. So we can create an identity vector. For example, in this case, we have ID variable and then X. For example, X is some kind of outer identity. For example, we have one person, one mother, and the children. So mother is same for different mother can be same for different child. So we are keeping these two identities: the individual children identity and the mother's identity. And similarly, we have the same two IDs for Y. So we can do again all these mergings. For example, we can do the inner merge that will include all the cases that matches the two identities, this ID and this ID in two data sets. So let's see. Now we have only two cases that are matching in two data sets. For example, ID 7 with A that is exist in both data sets that exist in both data set you can see, and the ID 8 with X value B. So two these two values should be available in both data sets. So these are the match cases basically, and we are keeping only match cases, that is the intersection of the two data sets. according to this vector. Now we have two IDs identities. You can group more than two identities and just in term of a vector. And similarly, we can do now we have more NS as we have different unmatched cases. We have only two match cases, these two, and most of the other have unmatched cases. And similarly, we can do other mergings, outer right, and then uh, outer right and outer left. And the last and the most important thing is cross join. Cross join means in most of the cases we need to repeat a data set according to some other data set. For example, we have patient's record for more than two times. So uh, we have a data set with only unique patients and their records, and we have another data set that is the data set for the same patients for other some time period. And basically uh, there is a cross joining. Basically we want to write the value of data to corresponding to each value of each observation of data set one. So for that purpose we use cross join. So let's see, we are just again using the merge function x and y and then by null. It will just join, just match the values according to cross join. For example, we have one case of x, then according to the first case of x we write all the values of y, and then for second case of x we write all the values of y, and corresponding to third case of x we write all the values of y. So this may be in the cases where we are we there is a matching for example, we have a, a mother and different children, then the value of mother will be repeated for each children for increase in all children. For example, a mother has four children, then uh, the data corresponding to the four children first children will be repeated for mother one, and second children will be repeated for mother, and third children will be repeated for mother. So then uh, we can just merge the data as a cross join function. So let's see how it works. Now in this case we have I have just included the first two variables of data one, and only last column of data two. So to just explain, we have x, y, z. We have id and x from first variable, from first data set, and the y2 from the second data set. So let's see how it works. It will get we will get 100 observations basically, as we have 10 observations in first data set, and corresponding to each observations we are repeating data set 2, so we will get 100 observations. You can see just for first case of x we have value of y, for second case of x we have value of y, for third case of x we have first value of y, and so on. This is the first value of y. Y is still at first, And then from here y is started. The second value of the y is started from here, and this is repeated. Basically the value of uh, the value of second variable is repeated 10 times according to the data for first variable. So these all are about the merging different data sets. If you have any question related to merging data, you can always write in comment section.